Okay, so first question is, consider the following reactions. That is, there is sequence of reactions. First is para-fluoro-nitro-benzene. So we first treat it with dimethylamine. Then X is formed, and that X, when treated with Sn plus HCl, okay, then it is treated with NaNO2HCl, and at the end H3PO2 and 0 to 5. This is dimethyl formamide. Yes. So SnHCl, if we talk about SnHCl, because dimethylamine, the reaction with fluoro-nitrobenzene in the presence of DMF. DMF means dimethyl formamide. Now you know fluorine and nitro both are electron withdrawing groups. So these electron withdrawing group decrease the electron density on the ring, and therefore you know attack of the nucleophile, that will be enhanced. Means nucleophile can attack, right? So now let us see where this can attack. Dimethylamine. So dimethylamine yes. So with respect to nitro or fluoro? Why with respect to fluoro? You know, nitro and fluoro. So which one deactivate more? Yes. So it deactivate from ortho and para. So attack takes place at a meta, but that is of electrophile. But at the same time, if we have this dimethylamine, this is acting as, I don't know what happened, actually PPT is not working. attack of this, let us say it takes place at see at the end NO2 will be removed, you know, SnHCl convert NO2 into NH2, N2Cl and H3PO2 will remove it. Okay, but question is, what is the role of last time it is working perfectly, but I will restart the program. Even those are not saved questions. Actually, I think I have not saved it first because those images are also removed. Okay, okay. No, means from the PPT. Yes, yes. So we can sit. No. Is it visible? Let's go to that slide first. Okay, so we have this question. Consider the following sequence of reactions. It is para fluoronitro, means 4-fluoronitro benzene. First we treat it with dimethylamine, right? So actually nitro group will remains as such, but fluoro will be replaced by this group. Keep in mind, whenever we have a fluoro or SO3H, these groups are can be easily replaced by another nucleophile. What? See, actually fluorine can hold negative charge effectively. So that's why that can be removed. Same is the case, when you have done this question, I hope. Benzene sulfonic acid, when it is treated with NaOH. So what we get? We get, yes, ONA, and then on hydrolysis we get phenol. So SO3HF, they are weak nucleophiles because they are not willing to share its electron or to donate electrons. Okay, so they can be easily removed. So that's why the X product is this one. Now after formation of this product, now NO2 can be removed easily. So that means C option is correct. Is it C correct? Because first NO2 with the help of SnHCl, yes, no, I have made the sequence, but actually we have started it. That's why I continue with it. So SnHCl, so it will be like this. Now after NaNO2 plus HCl, it is diazotization reaction. So we get N2 positive, Cl negative. And then with H3PO2, it is leads to removal of N2 positive, Cl negative. So we get this product along with other products, N2 and all. Okay. I think fluoro, this from X to Y, there must be a question, but from this fluoro, replacement of fluoro by dimethylamine, that is not in your syllabus, so might not be asked. So this one was the first question, right? So this is cyclopropyl group. So it is cyclopropane carboxylic acid. So first we treated with ammonia. So when we treated with ammonia and then on heating, acid base reaction takes place. Yes. So first we get this one, and then on heating water is removed and we get amide. After this one is A, right? So this is A. Now this A, when treated with KOH and Br2, what is the name of this reaction? So this is Hoffman bromide degradation. So CO is removed. So this product is formed. Now when it is treated with chloroform in the presence of KOH alcoholic, what will happen? What is the name of this reaction? No. For amine, it is a test of amine. It is carbylamine reaction. So this one is actually, it is a test for primary amines. Sorry. So it is carbylamine reaction, and it leads to the formation of carbylamine, means isocyanide. Now, which on hydrolysis, when it is hydrolyzed, what is the product? X is so when it is hydrolyzed, you know, we get this carbon turns into carbon dioxide and yes, it turns into H2CO3. It will give H2CO3 and we get this product. That means X is H2CO3. Yes, because we start adding H and OH on both sides. Okay. So that means D, this X is same as that of B. Okay, no, it is KOH, and yes, it is B. Oh, sorry. Just tell me. No, it's not given. That type of reaction is actually the tests are framed just to put a fear in the mind of the students ki, oh, we don't know this type of question, these type of questions are asked and they are not given in the NCERT. I saw the IISER and NET questions all are from NCERT. So means few things are there which are from deliberately added. Okay, in the last reaction, all the other reactions are from the NCERT. Only this one is from the other part. Okay, so yes, because nitrogen is more electronegative, so pi electron shifting takes place towards nitrogen. So nitrogen get positive and carbon negative. Okay. Yes, nitrogen means nitrogen will get a positive ion. because negative it got negative charge on it, and carbon gets positive charge, so it gets negative. Okay. It will give, I think, H2OH, yes, H2CO3. X will be this, see, cyclopropylamine, and this is your C. So D should be, sorry, X should be similar to B. I hope B should be the answer. What is the answer? Now got it? Okay. See, if let us say you don't know the last step, okay? Up to A, it is very much from the NCERT. Up to B, again from NCERT. Up to C, again this is the reaction, carbylamine reaction from NCERT. Say same CSCl3 and KOH are used in Raymond-Diamond reaction even. And here it is actually amine, primary amine. So keep in mind, it is a test for primary amine only. It is specific test for primary amine that has obnoxious smell, bad smell. This is isocyanide, and that indicates the, yes, 1 degree amine. Primary aliphatic as well as aromatic, both. So up to C you have approached, okay, you have reached up to this. So now you know there is N and C. So obviously see the previous one. This is A. So A cannot be formed, reason being it is N and C. C, it is already C, so it cannot be formed. So what is left? So means you can make an intelligent guess, because answers are already given to you. Now next is, see, again KOBr means it is KOH plus Br2. Actually, when KOH and Br2 react, it will give KBr plus KOBr and H2. So in this way, if it is written as KOBr, or say in one more question, yes, NaNO2 HCl. Yes, same is the case here. So you know pH, CH3, yes, it is now NH2, the CO is removed. I think there is no confusion now. See here pH, HCH3, but you know we are not touching this carbon, so its configuration remains as such. Okay. So A option is correct. Now propane 1-amine, this is propane, sorry, propane 1-amine. Now propane 1-amine when react with NaNO2 plus HCl, So keep in mind it behaves like this. HNO to give HONO. So it gives alcohol, nitrogen and water. So CH3, CH2, CH2OH. It gives a mixture does not contain. Okay, it gives a mixture of product. Propane 1-amine on reaction with NaNO2 and HCl gives a mixture of products. Okay, this one is the obvious product. That means yes, that's what, if HCl is in excess. Sorry? C can be formed. Because it is NaNO2HCl aqueous solution. Okay. So that means A cannot be formed. There is a more than one option or only one? So that means mixture does not contain first one. Actually, when you have this type of structure, there may be an elimination reaction. To some extent water is removed. Means there is a possibility, but major product is B. Okay, because here we are forceful to include it. Means forcibly we are including D. Because A could not be formed because cyclopropane is least stable. So it will always try to open up. So how do we get cyclopropene by propane 1-ol? That is not possible. Okay, that's why we means this is the least probable product. How do we get A? Propane 1-amine on reaction with NaNO2 and HCl gives a mixture of products, but mixture does not contain anyhow. Leave it, I will get back to you after solving it. Next, identify the final product of the following sequence of reactions. So first is N2O5. Yes, actually I think why it is written, reason being we have nitrating mixture like this. It will give NO2 positive, but now if we have N2O5, it is an anhydride of nitric acid. Okay, so because there is no other option which we can take into account, so obviously it should be HNO3 and H2SO4. They are deliberately using those reagents which are not in our syllabus, so that students are forced to join some best coaching institutes. This is the psychology of the students even, because if they don't know the particular question, they are forced to join somewhere. Okay. So now next is chlorination. So obviously NO2 group is meta directing. So meta product is formed. Now yes, H2 PD carbon, so it turns into NH2. And then NaNO2 HCl, again formation of diazonium salt. And with water we get OH and Cl. That means B option should be correct. Which one is the option? B. Okay. So see, let us say you don't know first step. Only first step is difficult. Rest steps you know. See, chloro is in 3 options. Okay. Hello. So as chloro is in 3 options and that is at meta position, that means the group attached here should be meta directing. And again H2PD is there, that means reduction of that group takes place. And again there is NaNO2HCl, so that group should be converted into NH2. So if it is NH2, so H2PD convert NO2 into NH2. So it should be NO2. Means it is simply a guess. From your previous knowledge, you are just applying it to predict unpredictable. Got it? Even if you don't know the first reaction, you can figure out by looking at the other reactions. Okay. And at the end H2O, so obviously OH group should be attached. So whatever is there with N2O5, you know, from these steps you came to know that OH should be there. So there is only one option where OH is attached. Okay, because NaNO2HCl, that will obviously give N2 positive Cl negative. H2O, that will give OH attached to the ring. So in this way, if options are given, the question becomes simple sometimes. Okay. Next is, which is not the expected product in the following sequence of reaction? Okay. So first of all, we have HN, HO and H2. Hydroxylamine, and that is in excess. That means both the groups turn into, it gives double bond NOH. Okay. NOH, and then we treat it with concentrated H2SO4. Yes, and this is a name reaction. Name of the reaction is, this is a rearrangement, but again that is not in our syllabus. But anyhow, if it is given, you are right. नॉर्मल मैकेनिज्म अगर लगता होता तो आप, आई थिंक आप, सो मीन्स हाउ मेनी क्वेश्चन यू हैव डन? Okay, means including these questions? Okay, great. Actually, that is Beckman rearrangement. Yes, that Beckman rearrangement will give 6-membered rings. So that becomes C double bond O NH, C double bond O NH, because there is a movement like this. So which one is the expected product? What is the right option? C. Means it will lead to the formation of cyclic amides. So means that larger group will shift to hydroxyl, means so this one is larger group, right? So that will shift to hydroxyl, means so above all, six-membered rings are formed, either because when this whole larger group will shift to OH, that become C double bond O, and it become NH, again this one, again double bond O, NH, or if it is other way around, then that will be like this. Because in this case both the groups are on the same side. That means if there is an intelligent guess, see, they are on the opposite side. Yes. See. They should be on the opposite side. So most expected product is this one. Yes. And other may be there because, actually larger group will shift to oxygen, but because we write the expected products, so expected products, there may be minor products, there may be some minor products. So B and C are minor products, means B is least probable product, A, then D, and then B. C is impossible. But questions are really difficult, I must say. Means you are on the right track, no worries, okay, because these are not of your level actually. Okay, now relative strength of organic acids, these definitions you know better. Compound which furnish H plus ion in aqueous solution, that is areneous acids, and which are giving H plus ion in any solution, they are bronzed acids. That means all areneous acids are bronzed acid as well. Yes. Like NH4 plus, H3O plus, all areneous acids are bronzed acids. Lewis acids, the lone pair acceptor, means which are electron deficient, which have vacant p or d orbitals, like BX3, ALX3, ZNX2. Now, how do we measure the acid strength? So, to measure acid strength, we take into account K, that is acid dissociation constant. So, obviously, when acid is strong, that will give more H plus ions, and therefore its Ka value is higher. And if Ka value is higher, Pk value is lower. Yes. Now, inorganic acids, all the mineral acids are inorganic acids, and inorganic acids are completely ionized. They are strong acids, but if we even compare them, H2SO4 is stronger than HCl, which in turn stronger than HNO3. And if we talk about organic acids, alkane sulfonic acid is stronger than carboxylic acid, stronger than phenol, and then alcohol.
This is regarding, sir, I had a question.
Yes.
Sir, I checked if triacetoacetic acid have the pH difference and also in the case of H2SO.
Hmm.
The pH of triachloroacetic acid was lower. But then I said which one is the stronger acid? It said H2SO.
Actually, we will see Ka value. If pH is low, obviously that should be stronger acid, but it depends on Ka actually. Even in some books, HCl is given stronger than H2SO4. Because in mineral acid, there is a water leveling actually.
Sir, Ka is proportional to acid.
Yes. So obviously, if trifluoroacetic acid, trichloroacetic acid, its Ka is higher. If its Ka is higher than H2SO4, so obviously it should be stronger acid. Because actually it is a mineral acid, and even trichloroacetic acid is an organic acid. So organic acids are generally weaker acid than mineral acids. But if Ka is given and you compare on the basis of Ka, and obviously Ka is the right criteria to decide which one is stronger acid. So if trichloroacetic acid has higher Ka value, it should be stronger than H2SO4. I will check and let you know. Okay. So in organic acids, you know, RSO3H is stronger than RCOOH. Why is it so? Yes, because negative charge is more delocalized than in case of carboxylate ion. Yes, and all are equivalent like that. So to predict acidic strength, we see the conjugate base of the acid, that is the anion. If acid is strong, its anion should be stable. Means after removing H plus ion, the anion formed should be stable. So stronger acid has more stable anion. So stronger acid forms a more stable conjugate base. Means strong acid has weak conjugate base. More stable conjugate base means it is a weak base. Now what are the factors? So first is electron withdrawing group. So whenever we have withdrawing groups attached to the polar group, then that will increase the stability of the anion, because withdrawing group withdraw electron density from the negative ion, and therefore that increases the stability and hence increases the acidic strength. So see, we have RCOH, removing H plus, we get RCO negative. So electron withdrawing groups with minus M or minus I effect, that will make it more stable. And if there are electron releasing groups plus M or plus I, then this is hyperconjugation actually. Hyperconjugation, okay. So that will make it less stable. Now if we have inorganic, say like methane, ammonia, water, HF, so as electronegativity increases along the period, acidic strength increases. And if we talk about conjugate base, so conjugate base of obviously HF, fluoride ion, is more stable. That's why fluoride ion is replaced by dimethylamine in the previous reaction, okay. So least stable anion is CH3 negative. So electron negativity dominates over size decrease along the period. So along the period, electronegativity decides the order, and as we go down the group, size will decide the order. So as size increases, bond length increases. As bond length increases, bond strength decreases, and therefore it is easier to break the bond, and therefore it will give H plus ion readily. So that's why HI is most acidic. On the basis of electronegativity, HF should be more acidic, but on the basis of size, HI is stronger acid. So down the group we will see the size, and along the period we will look at electronegativity. Now organic acid that I told you just now. This anion is more stable because negative charge is delocalized on 3 oxygens. Here it is delocalized on 2 oxygens. Here negative charge moves from oxygen to less electronegative carbon, and that's why phenoxide ion is less resonance stabilized. Phenoxide ion is less resonance stabilized than carboxylate ion. And in case of alkoxide ion, that you know, alkyl group is electron donating, so that will decrease the stability. That's why Ka value increases up the series. Explanation is simple. This one is more stable. Carboxylic acid is more acidic than phenol, which in turn more acidic than alcohol, because in carboxylic acid both the carboxylate ions are equally stable. It should be aromatic. Okay. In case of phenol, you know, there are more resonating structures than carboxylate ion, but negative charge is partially localized on oxygen. So in sulfonic acid there are 3 equivalent structures. In carboxylic acid there are 2 equivalent structures. In phenoxide ion, though it has 5 resonating structures, but 3 have negative charge at carbon, so they are less stable and less contributing. And alkoxide ion does not have any resonance stabilization, though although it is electron releasing group, so that will increase the negative charge, means destabilize the negative charge. This is the order of acidic strengths. This one, see, phenyl benzene sulfonic acid and alkane sulfonic acid. Same is the case here. Okay, so these are the aliphatic acids. What is the order of their acidic strengths? Which one is most acidic? Yes, number 11 should be most acidic, and then
number 7.
yes, and then
According to the order, it should be number 2 after 11.
yes, 11 then 2. Okay, great. And then 7.
11, 7, 3.
Hmm. Yes. Why not 1?
So because it is even lesser acid.
But you know, carbon, in this case, there is sp hybridized carbon.
Yes.
This is more electronegative than sp2 or sp3 hybridized nitrogen. But sp hybridized carbon is less electronegative than oxygen, even if it is sp3. I think so. So see the order. see 11, that you have already predicted. 11 to 7. 7 is okay, benzoic acid, then it is 3, okay, carboxylic acid, then it is phenol, then it is water, and then 1. After 1 it is 4. Got it? Because of the electronegativity concept. Because along the period you will take into account electronegativity. Actually, sp hybridized carbon is more electronegative than sp3 hybridized nitrogen because of the electronegativity. Okay, that's why then it is 4, 5, okay, 8, what is it? Okay, sorry, alkene, and then it is alkane, cycloalkene and cycloalkene. So here when you increase the withdrawing groups, 1 chloro, 2 chloro, 3 chloro, acidic strength increases. Fluoro, if it moves away from COH, acidic strength decreases. HCOH is more acidic than CH3COH. Yes, one question I always forget to tell you. Out of water and methanol, which one is more acidic? Yes, very good, very good. That's what I wanted to tell you, that methanol is more acidic than water because it is an exception to general rule. Okay, CH3COH, obviously it is more acidic than CH3CH2COH because plus I effect here it is more, here plus I effect is less. And as carbon atom increases, means alkyl group increases, you know, plus I effect increases, and that's why acidic strength decreases. And if, see, there are 4 carbons, but if you see this carbon, it is attached to 2 carbons. This carbon directly attached to COH is attached to only 1 carbon. Here carbon directly attached to COH is attached to 3 carbons. So it is more electron releasing than this, and which in turn more releasing than this. Means it is least, it has least plus I. That's why it is more acidic than this. Fluorochlorobromoiodo, you know, just see fluorine is more electronegative than chlorine, then bromine, then iodine. Yes, nitro has more minus I effect. Just see the order of minus I effect. No. Only minus I. So CH3 thrice N has higher minus I effect, then NO2, then CN, then fluoro, and you know methyl is releasing only. Again sp3 hybridized carbon, sp2 hybridized carbon, sp hybridized carbon. So sp hybridized carbon is more electronegative, therefore it is more acidic than sp2 and then sp3.
Sir, do you have questions on this topic?
Okay, I will share. So electronegativity of sp hybridized carbon is more than sp2, which in turn more than sp3 because of greater S character, 50%, 33.3%, only 25%. Dicarboxylic acids. It is very interesting part. Actually, oxalic acid has two H plus ions. So when we remove first one, it becomes COO negative. Now, O negative, COO negative, they have plus I effect. So when they have plus I effect, what happened? Yes, it will decrease acidic strength. It has plus I effect. This group has plus I effect. And when both CO negative again, so Ka1 is greater than Ka2. Here it has minus I effect, right? Here it has plus I effect, and that's why Ka1 is always greater than Ka2. That means first one is stabilizing, second one is destabilizing, and at the same time when negative ion is formed, you know, this COH has minus I effect. Okay, minus I is written about COH. Okay, CO negative has plus I effect, so COOH has minus I, and therefore it stabilizes this anion. Here COO negative both have plus I, but one will release electron towards the other, so it will decrease. You can simply see COH first and CO negative in the next, because COH negative will affect the removal of this H plus. At the same time, you can write it like this. So there is an intramolecular hydrogen bonding even, because 5-membered ring is formed. So you know, whenever 5 or 6-membered rings are formed, that is stable. Chelate formation takes place. So removal of dicarboxylic acids are not given in syllabus, but there is IUPAC name, oxalic, malonic. Malonic. Yes. No. Yes. OMS. Yes. Oxalic, malonic, succinic, glutaric. Okay, in case of polybasic acids, it is always true for successive acid dissociation constants always have order Ka1 greater than Ka2 greater than Ka3, because when one H plus ion is removed, that become anion, and you know, removal of cation from the anion is difficult. So that's written, second H plus ion is taken out from a negatively charged species, so it is difficult. Okay, it is already written. So Ka1 of first is greater than second, second is greater than third, third is greater than fourth, because you know, they are releasing groups, more number of carbons, more releasing effect, and less acidic strength. Now maleic and fumaric acid, when you compare the acidic strength of maleic and fumaric acid, they are geometrical isomers. Maleic acid is cis isomer and fumaric acid is trans isomer. So when first H plus ion is removed, see, first H plus ion is removed, we get this type of product. Now OH of one and O negative the other, they form hydrogen bond. So when hydrogen bonding is formed, removal of second H is difficult. So first tell me, what is the relation between Ka1 and Ka1 dash? Which one is stronger? Which one is higher value? Yes, Ka1 is greater than Ka1 dash. Why? Because after removing H plus ion, the product formed is stabilized by hydrogen bonding. Anion is stabilized by hydrogen bonding. But in fumaric acid, it is not possible. But its disadvantage is that one, this hydrogen gets bonded. Now its removal is difficult. So Ka2 is less than Ka2 dash. So Ka1 is greater than Ka1 dash, but Ka2 dash is greater than Ka2. Now acid strength of aromatic acids. So it depends upon, and again whenever we have benzoic acid, there is an ortho effect, and that is acid strengthening effect. Just like in aniline, that is base weakening effect, here it is, yes, steric effect, or we can say ortho effect. Second is electronic effect of substituents, and third is intermolecular intramolecular hydrogen bonding. So ortho effect first. So whenever we have 1,2 disubstituted benzene, if the substituents are bulky, then what happened? Due to that steric repulsion, that group go out of plane with respect to benzene ring, because resonance takes place only when all are in plane, means all are sp2 hybridized, and that should be in plane. So because of the change in this planarity, what happened? Conjugation, resonance will be disturbed, that is decreased, and this is called steric inhibition of resonance or ortho effect. So whenever we have a ortho substituted benzoic acid, and that is due to steric inhibition of resonance, conjugation between benzene and carboxylic acid is decreased, and the plus M effect of benzene ring to the carboxylic acid is decreased, obviously if a resonance does not take place. So acidic strength increases with respect to benzoic acid and with respect to meta and para substituted benzoic acids, in spite of any electronic effect of substituent. First one, if group is NO2 R X COOR COH, accept these groups. So whenever we have group, so COH goes out of plane. So if COH goes out of plane, its acidic strength increases. Okay, these are nitro groups. So at ortho and para position, nitro group has minus I as well as minus M effect, minus R effect. but at meta position it has only minus I effect. So tell me, what is the order of acidic strength? Yes, because of ortho effect as well as minus I is maximum. Yes, ortho, para, then meta, then so it is ortho, para, meta, and then benzoic acid. Now group has only minus I effect. It is very simple, because minus I effect is maximum at ortho and minimum at para. So all of them are more acidic than benzoic acid, but ortho is most acidic, then meta, followed by meta, then para, and then benzoic acid. So it's ortho, meta, para, benzoic acid. Same is the case with chloro, because in chloro again there is minus I as well as plus M plus R, but minus I is dominating. So ortho, meta, para, benzoic acid. What about this? If plus M and minus I effect, but plus M is dominating. These are the groups: COOH, OCH3 ortho, meta, para. Yes, due to ortho effect, ortho will be again, but then it is meta. Meta and ortho almost same. Why ortho is going up? Yes, and para is least because of electron releasing effect, because it behaves like electron releasing group. Okay, methyl group, ortho, meta, para.
So hyperconjugation is favorable for acid.
Actually, hyperconjugation means also electron releasing effect. So it is not in favor. But where is the ortho effect? It should be ortho, then benzoic acid, and then metapara. Yes, it is dominating. See, methyl, ethyl, propyl, isopropyl, tertiary butyl. Okay, all of us have ortho effect, but ortho effect is most prominent in this case. Yes, because ortho effect means steric inhibition of resonance, SIR. So steric hindrance more, ortho effect is more. So that's why, see, as these groups increases, their acidic strength increases. Bulkier the group, more is the ortho effect and stronger is the acid. Again, though this is a bulkier than these two, but these effect on both sides. See, on this side it is free of steric hindrance. That's why it is more acidic than this. What about this? This is very simple example. Which one is most acidic? Yes, nitro. Nitro group has more electron withdrawing effect. Both minus I as well as minus M. That is 5,4 because 4 is electron withdrawing group. See, these two are less. See, if we compare, first we write it like this. 5 and 4 are more acidic than 1. 2 and 3 are less acidic than benzoic acid. Because here they are electron releasing groups. In this case, they are electron withdrawing group. Then we take into account the more withdrawing effect is nitro. So that's why 5th is more acidic than 4. Then it is first. Now out of 2nd, 3rd, methyl is less electron releasing than OCH3. So that's why it is 2nd and then 3rd. Here hyperconjugation as well, okay? So it is 5, 4, 1, 2, 3. What about this? Methyl, methoxy. It is 5, 4, 3, 1, 2 because nitro group has a higher minus I effect than chloro. Chloro has higher than methoxy, and you know methyl has plus I effect. Yes. Oh, almost same, but one is at ortho position. Is 5, 4 and then 2, 3, 1 because they have very large minus I effect, though it has minus I effect, but it is less. Such type of questions are misleading actually because student cannot figure out how do we decide. Okay. Yes. But keep in mind, whenever nitro and chloro groups are there, they are more electron releasing, more electron withdrawing. I mean, they have higher, they are at the higher end of minus I effect. Now, inter and intramolecular hydrogen bonding. So, intramolecular hydrogen bonding due to ortho effect is effective only in phenols and not in benzoic acid because that becomes 7-membered ring in case of benzoic acid, like this. See, if there is an intramolecular hydrogen bonding, 1, 2, 3, 4, 5 and it is 6-membered ring, na? So ortho anion stabilized by intramolecular hydrogen bonding because it becomes 6-membered ring. Is if we have phenol here, then it is more stable anion So that's why Ka value of ortho is greater than para, but boiling point of ortho is less than para, because ortho group, in case of ortho, that is stabilized in its own, and that's why its boiling point decreases, even solubility decreases, melting point decreases, and we can separate them by steam, because they are steam volatile. Ortho is steam volatile. Okay. OH group, in the first case, on both the ortho positions are occupied by OH. In the second case, only one position is. Which one? Yes, OH group does not have ortho effect, but it has a minus I effect. So minus I effect of, in case of first it is maximum, in the second, and then it is third, followed by fourth. So ortho effect is operative only in ortho substituted benzoic acid, not in ortho substituted phenols. Okay, so that's all for today. Tomorrow, as in the phenol we have done. Okay, yes, phenol, benzoic acid, amine. There, so we will take up nucleophilic substitution reactions. SN1, SN2, or okay, even E2 I will take up. Okay. Yes, I will say.